There's a few levers you can pull to better suit your irrigation to your production goals. There's ways of making sure that you're not starting too late, methods for figuring out the right amount to apply and how frequently to apply it, and indicators for when to finish up your irrigation season. There's two approaches to consider when you're deciding on when to start your irrigation season. You can look at the moisture demand from your plants, or you can look at the moisture content of the soil. The latter is fairly simple, and you want to start your irrigation season when your soils start drying out. You can follow the hand method on this slide by digging a hole, taking a sample of soil and trying to form a ball in your hand. If you've identified that the moisture level is between 75% and 50%, you can start irrigating. And if you've got a soil moisture probe, that'll work really well too. Just track where your moisture levels are and then irrigate when you hit your refill line, and definitely before you hit your stress line. The other method involves calculating the water usage of your plants. Plants use water via evapotranspiration, or ET, and we call the initial calculation ETO. ETO represents the water usage of a healthy 15 centimetre tall pasture, which is used as the reference crop for the equation. But we can adapt this calculation to fit any crop really. ET is tightly influenced by the weather, and so it can be reliably calculated using a few simple sensors on a weather station: wind speed, solar radiation, temperature, and humidity. Higher temperatures, more solar radiation and wind, and lower humidity all lead to higher evapotranspiration. You can access daily ET figures from most weather stations, and the ET number will be in millimetres per day, which makes for an easy comparison to rainfall. The graph on the right shows historical monthly rainfall and monthly ET data for Hobart. The red horizontal line is median rainfall, and the dipped line is ET. Highlighted in yellow to show months of the year when ET is higher than rainfall, and in blue to show the times of the year when ET is below rainfall. So you've got a rainfall surplus in winter and a large rainfall deficit either side for summer. A good general rule is to start irrigating when weekly ET exceeds weekly rainfall, so that you can carry some of that stored soil moisture from winter into summer. Coming out of winter, you've got the advantage of having a store of subsoil moisture. If you start your irrigation season too late, then you risk using up that subsoil moisture in spring. In spring, average ET might only be 3 millimetres a day, whereas it's usually double that in peak summer. And when daily ET is 6 millimetres, and say you've got a pivot that's only able to apply 8 millimetres at a time, and that's without accounting for application inefficiencies, then at most you've got about 2 millimetres spare to recharge the soil. And this leaves very little room for error. If you expect to have a high water demand in summer, then the best thing you can do for peace of mind is to try and keep your subsoil moisture intact for as long as you can throughout spring, so that you've got that buffer there when you need it in summer. The other thing to consider with starting too late is that you might expose your plants to water stress. Because plants are adapted to water stress, they'll instinctively slow down their growth. Some crops will have better or worse resiliency, but there will usually be a lag after water stress, a sooking period before they start growing back at optimal speed again, and this could have an effect on your yields. So once you've decided to turn on the irrigator, what amount of water do you apply? Firstly, work to the soil. What's the infiltration rate? If you're irrigating to that, then you won't be losing any water to runoff. I recommend finding out the right amount to apply and then adjusting the frequency that you apply that amount. The bigger question is, how much water do you need to use? The ET calculation is useful here because, put simply, we want to know how much water our plants are using. And to make the ET calculation useful to what you're growing, you can apply a crop factor. That's a crop-specific and growth stage-specific value. Using this method, you're going to keep track of what crop growth stage you're at and then match that to the right crop factor so that you can adjust daily ET to be reflective of your crop, and then subtract any rainfall that you might have gotten and then irrigate to the deficit. The FAO has freely available crop factor progressions for many different crops and tables with the approximate number of days for each growth stage too. You can also decide how much irrigation you'll need by using a soil moisture probe and irrigating when the soil gets dry. Most people using probes develop a refill line based on their soil type and the crop that they're growing, and then they just turn on the irrigator when soil moisture reaches that point. Refill lines will be different for everyone depending on your soil type and structure and the crops that you're growing. But if you have a good idea on your soil type and you know its water holding capacity, then you can use the FAO's research on raw fractions to help you deliver an accurate refill line so that you're always keeping moisture in that readily available zone. Raw, or readily available water, is the water in the soil that is easily extracted by plants. So raw is the fraction of plant available water that plants will happily use before they start slowing down their growth to cope with the water shortage. All crops are differently adapted for water shortage, so raw fractions will vary quite a bit from crop to crop. To calculate the raw of your soil, you need to find out the maximum rooting depth of your crop, and then using the hand texturing method, you can determine the texture of your soil, and then find out the plant available water content for that rooting depth. Then you want to multiply that number by the raw fraction on the FAO website, and your answer will be the fraction of plant available water that is readily available. So in this case, for broccoli on a clay loam, we've got 48.6 millimetres of raw, so we can set our refill line 48.6 millimetres below the full point on our soil moisture graph. But as with anything, be a bit sceptical and validate your refill line by digging holes and feeling how damp the soil is by hand from time to time to get a better idea of what your moisture level is really like. How should you irrigate differently if you've got a paddock with variable soil types? In the last video, we covered differences in water holding capacity for the different soil types. So for irrigation, let's take that graph minus the unavailable section. When we do that, it becomes really clear that sand has the lower plant available water section. And if we're dealing with any one of these soils by themselves, then we'd irrigate them really differently. The clay soil, we could apply more water because it could hold it. But if you're dealing with variability, you always want to work to the lowest readily available water quotient. There's no point in maximising our water usage in the clay because that'll simply drain out the sand. Meanwhile, we still want to keep our moisture level in the clay soil in that readily available section, so that narrows our window even further. Working with a small window like this means that you'll need to irrigate less more often. The same irrigate less more often rule applies for shallow soils, particularly those that are shallower than the rooting depth of the crop, and for soils with slow infiltration rates. Ideally, you want to slow down the rate of application on these soils too, or double irrigate. So you can use your first pass of water to soften the crust or pacify those hydrophobic compounds, so that by your second pass with the irrigator, you can actually get some infiltration through. The final section, when to stop irrigating. This will be different for every crop, but it's a particularly relevant question for people growing perennial pastures. Essentially, you only want to irrigate if it leads to growth, and if it's gotten too cold, then the water you're applying will go towards winter refill. This is the case for the graph on the left. Water's gone in, there's been rain, and moisture's gone up, but nothing's using it, it's just staying stagnant. Soil moisture probes are a fairly handy way for determining whether or not your plants are growing later in the season. After an autumn rain, you can wait about 7 days, and if you don't see diurnal stepping throughout the profile, then it's very likely that your plants have entered dormancy. Diurnal stepping is the daily fluctuation in water use, where water is used in daylight hours and it's not used during nighttime hours. It's a reliable indicator for plant water usage because we know that plants only grow when there's sunlight. The image on the right shows what diurnal stepping should look like. If you're applying water and not seeing diurnal stepping, then this could be because it's gotten too cold or because you've let the soil dry out too much, and it means that your plants won't respond to irrigation and you'll have to wait for warmer weather in spring to break the dormancy. So to recap, it's critical to start your irrigation season on time. By keeping track of soil moisture levels and ET, you can hopefully bring some of your stored soil moisture into summer where you'll need it most. ET and soil moisture will also be your main tools for scheduling irrigation, and by choosing the right crop factor and the right refill line, you can perfect these tools. And within your irrigation plan, you also want to pay attention to soil infiltration rate and soil variability so that you're using the water you've got efficiently.